The world has never needed rare earths more than it does today, which is why governments are suddenly investing billions, companies are redrawing supply chains, and countries, including India, are racing to secure them. But here's the paradox. Rare earths are found across several countries. Even India has some of the world's largest reserves. Yet one country dominates the supply chain. And that's exactly the dominance the rest of the world is now racing to break. The race became impossible to ignore in 2025. China introduced export controls on several medium and heavy rare earth elements and related products. Companies could no longer simply buy these materials and they now needed export licenses. Almost overnight, governments and manufacturers around the world began asking an uncomfortable question. What happens when one country controls materials that power everything from electric vehicles and wind turbines to fighter jets and advanced electronics? The International Energy Agency recently warned that if these restrictions were fully enforced, they could expose nearly $6.5 trillion worth of downstream manufacturing outside China. And that includes industries like automobiles, electronics, aerospace, renewable energy, and defense. But before we understand why the world is worried, let's first understand what rare earths actually are. Despite the name, rare earths aren't actually rare. They're a group of 17 metallic elements found in many parts of the world. And the challenge isn't finding them. It's all about extracting and processing them economically. And if we look at where these reserves actually are, one thing immediately stands out. China has the world's largest known rare earth reserves, estimated at around 44 million tons. Brazil comes next with 21 million tons. India ranks third with nearly 7 million tons. Australia has around 5.7 million tons, followed by Russia with 3.8 million tons. So here's the interesting part. If rare earths are spread across so many countries, why does the world still depend on China? Because mining is only one step in a much longer journey. Before these minerals can power an electric vehicle, a wind turbine, or even your smartphone, they have to go through several stages of processing. The ore is first mined from the ground. It's then concentrated, chemically separated into individual rare earth elements, refined into high purity oxides, converted into metals and alloys, and finally manufactured into powerful permanent magnets. Those magnets then go into everything from electric vehicles and industrial robots to wind turbines, smartphones, and advanced defense systems. China started investing in rare earths decades ago. For years, it accepted the high costs and environmental challenges of processing these minerals, while many other countries either shut down processing facilities or chose not to invest in them. At the same time, it built capabilities across the entire value chain, from mines and chemical processing plants to magnet manufacturing and the industries that actually use these materials. And that long-term strategy created a powerful advantage. Today, China accounts for around 60% of global rare earth mining. But that's only part of the story. It controls nearly 91% of rare earth processing and refining and produces roughly 94% of the world's permanent magnets. And that's the real bottleneck. Because even when rare earths are mined in Australia, the United States, or Africa, they often still travel to China before they become the magnets that power countless electronic devices. So what exactly makes these elements so valuable? The answer isn't the minerals themselves, it's what they make possible. Take electric vehicles, for example. Global EV sales crossed 20 million vehicles in 2025, and many of these vehicles use permanent magnet motors because they're compact, efficient, and powerful. A single EV motor can contain around 1 to 2 kilograms of rare earth permanent magnets. Now multiply that by millions of vehicles being produced every year, and it's easy to see why demand is rising so rapidly. Renewable energy is another major driver. Large offshore wind turbines can require hundreds of kilograms of rare earth permanent magnets. These magnets make the turbines more efficient and reliable, helping generate electricity even in challenging wind conditions. As countries continue investing in clean energy, the demand for these materials is only expected to grow. Then there's defense, a sector where performance matters far more than cost. Rare earth elements are used in fighter aircraft, missile guidance systems, radar, sonar, satellites, and precision weapons. They're also critical for advanced communication and surveillance systems. In fact, many of the technologies that define modern warfare depend on these materials. And the same is true for robotics. As factories become more automated and companies race to develop humanoid robots, the need for compact, lightweight, and energy-efficient motors is growing rapidly. Permanent magnets made from rare earth elements are what make many of these precise movements possible. And of course, there are the products most of us use every day. Smartphones, laptops, hard drives, speakers, and even MRI scanners all rely on rare earth elements in different ways. Most of us never see them, but without them, many of the devices we now take for granted simply wouldn't work the way they do. So rare earths sit at the heart of almost every technology that's expected to shape the next decade, hence making them indispensable. This brings me to India. And here's where the story gets interesting. India has the third largest rare earth reserves in the world. Yet despite that, India still imports thousands of tons of rare earth permanent magnets every year. Now, how can a country so rich in rare earths still depend on imports? Because once again, the challenge isn't what's underground, it's everything that happens after it's mined. Last year alone, India imported more than 53,000 tons of rare earth permanent magnets, highlighting how dependent its manufacturing ecosystem still is. Now, that dependence is becoming harder to ignore. India wants to become a global manufacturing hub. It wants to build more electric vehicles, scale up electronics production, expand renewable energy, and strengthen defense manufacturing. Every one of these ambitions increases the need for a secure supply of rare earth materials. Recognizing this, the government has begun shifting its focus beyond simply mining more minerals. It has approved a 7,280 crore rupees incentive scheme to encourage domestic rare earth permanent magnet manufacturing. It has also launched the National Critical Minerals Mission by strengthening partnerships with countries like Australia to diversify supplies and develop processing capabilities. The goal is to build the entire value chain from mining and refining to magnet manufacturing and advanced products. Well, of course, that won't happen overnight. China spent decades building its dominance through sustained investments, industrial policy, and manufacturing scale. India is beginning that journey. But if it succeeds, the rewards go far beyond reducing imports. It would strengthen India's position in electric mobility, clean energy, electronics, robotics, and defense manufacturing. All industries expected to drive the next phase of global growth. So we must understand that rare earths may not make headlines every day, but they'll quietly power many of the technologies that define the next decade. India has the resources, it has the ambition. The real question is whether it can build the processing and manufacturing ecosystem quickly enough to turn that advantage into global leadership. If you found this episode insightful, don't forget to like this video, subscribe to Tech Brew with Vandana Nair, and I'll see you in the next one.